Now here we see how to calculate the volume of a parallelopiped whose three coterminous edges are given to us as vectors. Okay, so as shown in the figure, we can see a three-dimensional figure called as parallelopiped. Okay, it's like it was originally a box which has been tilted by a certain angle. Now we see the three edges which are A bar, B bar and C bar. They are called as coterminous. It means that they have one point in common in all of them, right? So here, to find out the volume, first of all we write the fundamental formula, that is volume of the parallelopiped is given by the base area. That is, if you see, the base of the parallelopiped will be a parallelogram, right? So therefore the volume of the parallelopiped is nothing but base area of parallelogram multiplied by the height. Now where is this height? Okay, so let us draw that height. So from A bar, if we drop a perpendicular, now let's assume that somewhere it will meet the parallelogram, right? And if we join that with the coterminal point, we see that it will form a right angle, right? And this vertical segment is what is the height of the parallelopipe. Now to get the area of the base, we have seen that the base area, which is the area of the parallelogram, is given by the magnitude of cross product of the two adjacent sides of that parallelogram, which are B bar and C bar. So clearly mod of B bar cross C bar is the base area. Now to get the height, okay, that is h, if you observe that in the right angle triangle so formed, okay, we have to find out first what is the value of h. Okay. For that, let us consider that the angle made by A bar with the vertical direction, let it be theta, right? So therefore by simple geometry it's clear that the angle made by the vertical height with the A bar is also nothing but theta. Now if you see the hypotenuse of that particular triangle, which is A bar, okay, so therefore the mod of A bar is the length of that hypotenuse. Now to get theta, we'll have to imagine some vector which is in the vertical direction. Okay. Now we have to ask what is the vector which is in this particular vertical direction. Okay. For that we observe that if we take B bar and C bar and take their cross product, then we know that the cross product always lies in a direction which is perpendicular to both of the individual vectors. So clearly we can take B bar cross C bar as the required vector in the vertical direction. So that means angle theta is nothing but the angle between B bar cross C bar and A bar, right, as is seen from the figure. So therefore by using the formula derived from the dot product, we can say that cos theta is nothing but the dot product of the two vectors, that is A bar dot B cross C, divided by mod of A bar into mod of B cross C, correct? That means now to calculate h, now we know that h is nothing but mod of A bar into cos theta. So therefore taking mod of A bar on left side, we get mod A into cos theta is A bar dot B cross C divided by mod of B cross C. So therefore substituting that in height, this is the height that we are calculating. So therefore this is into, now this is just algebraic multiplication, it's not a vector product. Okay. So therefore here we have A bar dot B cross C, which is a cross product now, divided by mod of B cross C. So therefore the mod of B cross C will get cancelled, and what remains is A bar dot B cross C, and which is nothing but the scalar triple product or a box product of the three vectors a bar, b bar and c bar. So here we get a very simple and important interpretation of scalar triple product. If you have a bar, b bar and c bar as the coterminous edges of a parallelopipe, then the volume of the parallelopipe is nothing but simply the box product of those three vectors, right? So it's as simple as that. Now it does not matter in which order you consider the three coterminous edges. You can have ABC, BCA, BAC and so on. Of course, if you get a box product as a negative value or negative number, then you will have to take the absolute value because the volume cannot be a negative quantity, right? Now based on this, let us solve one simple sum. Find the volume of a parallelopipe having coterminous edges as 2i plus 5j minus 4k, 5i plus 7j plus 5k and 4i plus 5j minus 2k. So if we call these three edges as a bar, b bar and c bar, then we know that volume is given by their box product. And we are already aware how to calculate the box product, that is we write the respective coefficients. So on solving that, we get the answer. We will get it as 84 cubic units. We know how to solve or expand a determinant, right? So that is the first use of box product.